last time I was talking about Markov chains, and so we'll continue about the Markov chains, and we'll give several examples, and at the same time we'll be giving the different transition probability matrix, because what we have shown last time that if we know the transition probability matrix and if we know the initial distribution, that means I know the complete Markov chain. Okay? So, we will start from there. So, suppose x n is a Markov chain, with the transition probability matrix P, which is Pij, okay, which is Pij, and which simply means that probability x n plus 1 is equal to j given x n is equal to I, which is the ijth element of the matrix P. Okay. So, probability x n plus 1 is equal to j given x n is equal to I, that becomes equal to Pij, and remember that it does not depend on n, That means it is homogeneous across time. Okay, that's what. And from now on, actually, we will be mainly talking about those kind of Markov chains, where the transition probability matrix does not depend on time. Okay, so probability x n plus 1 j given x n is equal to I is equal to Pij. And what we have seen last time, suppose x n is a Markov chain with the transition probability matrix P, it means that then and if we know the initial distribution that is probability x naught is equal to I for all I, then probability x 0 is equal to I 0, x n is equal to I n can be easily computed, can be obtained. Okay. So, that is what we have seen last time, that if we know the transition probability matrix, which is capital P, whose elements are Pij, and I know the initial distribution, then I should be able to find out the joint probability function of x 0, x 1, x n. Okay. So, what I am going to give you now is several examples of this matrix P. Okay. That is what it is. Okay. So, let us look at example 1, which we have already considered last time also. Example 1. Okay. So, suppose y n is a sequence of IID, independent identically distributed random variables, taking non-negative values, taking non-negative integer values, such that probability y n is equal to I equal to A I, where A i's are non-negative, summation ai equal to 1. Okay, so this becomes a proper probability distribution, that yn is taking the value I, with probability ai, where ai's are non-negative quantities, summation ai is equal to 1. So, this is my yn, and now I am finding out, or I am defining different xn from there, and we try to find out what is the corresponding transition probability matrix. Okay. So, let us look at that. So, example 1, first time suppose let my xn equal to yn itself, n is equal to, rather n is equal to 0, 1, 2 like this. As I said, well, this is the most trivial example, because in this case also xn's are iid, because xn is same as yn. So, therefore, if I try to compute what is the probability that x n plus 1 is equal to j given xn is equal to I, well, my xn is independent of previous one. So, which is same as probability x n plus 1 is equal to j, which is simply nothing but. Okay. So, you can see that the ijth element becomes equal to aj. Okay. So, for any value of I, the ijth element becomes equal to aj, and therefore, if I write down the matrix P, so if I try to write down the transition probability matrix P, you can see that. So, this is basically the nth position, and this is n plus 1th position. So, n goes from 0, 1, 2, 3, 4 like this, 0, 1, 2, 3, 4 like this. So, what it says? From probability that x n plus 1 is equal to 0 given x n is equal to 0, which is same as probability x n plus 1 is equal to 0. So, which is simply nothing but a0, a1, a2, a3. Similarly, if you look at x n plus 1 is equal to 0 given x n is equal to 1, which is same as probability x n plus 1 is equal to 0. So, which is same as a0, a1, a2, a3. Okay. If you look at here, probability x n plus 1 is equal to 0 given x n is equal to 2, does not really matter what is this values, these are all same. So, this is the, so this is the transition probability matrix in this trivial case. In this trivial case, the transition probability matrix will simply takes that particular form. Okay. As I said, this is the most trivial example of this one. Let us move to the next one. We have done it already last time also. Suppose my xn, example 2, this is not going to change, and keep this one same. I am keeping this one same. Okay. Yn is a sequence of IID random variables taking non-negative integer values. Probability yn is equal to I is equal to ai. Ai's are non-negative. Summation ai is equal to 1. So, that remains same, and now I am defining my xn, which is y0 plus y1 plus yn. Suppose I define it like this, xn is equal to y0 plus y1 up to yn. Then we have shown this one, that now I have to basically compute what is my transition probability matrix. So, let us try to compute that. So, probability x n plus 1 equal to j given x n is equal to I, which is same as probability y0 plus y n plus 1 is equal to j given y0 plus yn is equal to I, okay, which is same as y0 plus yn is equal to I. So, I have my probability y0 plus y n plus y n plus 1 is equal to j, given y 0 plus y 1 is equal to I. So, you can see that this quantity becomes equal to I. So, which is same as probability y n plus 1 is equal to j minus I. X 0 equal to I 0, x 1 equal to I 1, x k equal to I. Okay. In this case, find probability x 0 is equal to I 0, x 1 is equal to I 1, x k is equal to I k, because I should be able to do it, because I know the transition probability matrix and I know the initial distribution. Okay. That is what it is. Okay. Let us move to the another example, which is an interesting one, which is called, it is a game theory actually, it is a game theoretic problem. So, suppose there are two players, it is a 2 persons zero sum game. Two persons zero sum game. Okay. So, suppose A and B are two players. And A has at any particular time point A has a small a amount of money let me put okay. A has a amount of fortune and capital B has small b amount of fortune. Okay, and both A and B are integers. Okay, A and B are integers. A and B are integers. A and B are integers. Okay. So, how is the game? Make it simple. Okay. Suppose you toss a coin, and if it turns out to be head, then A wins, then A get 1 unit of money from B, and if it comes out to be tail, then B wins and B gets 1 unit of money from A. Okay. Say the game is as follows. The game is as follows. If toss a coin, with probability of head equal to P, probability of tail equal to 1 minus P. If head appears, player A wins, and gets 1 unit of money from B, and if it is a tail, it is a vice versa. And if tail appears and if T appears, it is just the opposite. Okay, fine. I think the game is clear that at any particular time point, the player A has A amount of money, player B has B amount of money. There is no money is coming from outside, and that's a reason that it is called a zero sum game. That means if A wins, then B loses. If B loses, if B wins, A loses. Okay, so there is no money coming from outside, and you toss a coin. If probability of head is equal to P, probability of head is equal to P, and the probability of tail is equal to 1 minus P. If head appears, the player A wins, which basically means that he gets 1 unit of money from player B, and if tail appears, it's just the opposite. Okay, it just goes this way. Okay, so you can see that since there is no money is coming from outside, so the game stops whenever A gets all the money or B gets all the money. Okay, so the game stops as soon as either player A or player B gets all the money. So it is clear that if one person gets all the money, the other person becomes broke. He does not have any money left. Okay? B gets all the money. Fine. I think that game is fairly clear. Okay? Game is fairly clear. Okay? And they keep on playing the game. They keep on playing the game, and suppose xn denotes the amount of money at the end of nth game. Okay, fine. At the end of nth game, xn denotes the amount of money. Sorry, xn denotes the amount of money of A, of player A. Okay, so that is important. Okay, so I am looking at say xn is the amount of money of player A at the end of the nth game. So it is clear that if you look at from the player B point of view, it is simply nothing but small a plus small b minus xn. Okay? So clearly yn, which is small a plus small b minus xn, is the amount of money of B at the end of the game. Okay, so you can see that if I study xn, I can automatically study yn also. It is a simple scale transformation. Okay, fine. So let's see. Let's try to compute what is the transition probability matrix of xn. Okay, so let's look at that. Let's try to compute the transition probability matrix of xn. So what you want to compute? We want to compute what is the probability x n plus 1 equal to j given xn is equal to y. That's what I am trying to compute. Okay. By the way, you can easily, it's very simple to check that actually xn is a Markov chain. Okay. That means that probability that xn plus 1 is equal to j given xn is equal to I, xn minus 1 is equal to in minus 1, blah blah blah, x0 is equal to I0 is same as this one. Okay? So I leave it for you to check this one. It's a very simple thing, simple one. But let's try to compute. Okay, let me just put it here. First check that xn is a Markov chain. Xn is a Markov chain. Okay? And similarly, actually, Yn is also a Markov chain. Okay? And yeah, similarly check that Yn is a Markov chain. Okay? Both of them are Markov chain actually. Okay? So let's see what is going to happen. So probability that x n plus 1 is equal to j given x n is equal to I. That means, at the end of the nth game, player A has I amount of money and player at the end of the n plus 1th game, player A has j amount of money. Okay, so, what are the possibilities? Well, see, he can either win one amount of money or he will lose 1 unit of money. Okay. So, it is clearly that this j can be is equal to either I plus 1 or I minus 1. Okay. So, j is equal to either I plus 1 or j is equal to I minus 1. These are the two possibilities. Only thing I have to be careful that if my I reaches either 0 or a plus b. Okay? Yeah. So, it is j is equal to I plus 1, j is equal to I minus 1, and let me just put it here. Okay? Okay. Probability x n plus 1 is equal to j given x n is equal to I is equal to j is equal to I plus 1, j is equal to I minus 1 for I is equal to 1, 2 up to a plus b minus 1, okay, for I is equal to 1, 2 of a plus b minus 1. I will keep these two options and then we will see what are the values of j. If for I is equal to 0, I have to look at it separately, and for I is equal to a plus b. Okay. So, what is this one means? This one means that A has the fortune lying between 1 to up to a plus b minus 1. Here also A has the fortune is lying between 1 to up to a plus b minus 1. Here it means that the A became broke, he does not have any money left, and this means that A got all the money, I is equal to a plus b. Okay. So, based on that I should be able to do this one. Okay. So, now if j is equal to I plus 1, that means moving from I to I plus 1, that means it has to be head, because then only he is getting the money from B. So, that probability become P. Okay. If he is losing one amount of money, so it has to be tail, which is 1 minus P. Okay. And if I becomes equal to 0, I become equal to 0, what are the possibilities of j? J has to be is equal to 0. There is no other way, because the game has stopped there. So, from that time points onwards, that there is no, he is not going to gain or lose anything. So, in this case my j is equal to 0. If I is equal to 0, j has to be is equal to 0, and which basically means for I is equal to 0, j has to be is equal to 0, that is with probability 1. Okay. And if I is equal to a plus b, then j also has to be is equal to a plus b. J also has to be is equal to a plus b, and that becomes also equal to 1. Okay. So, that becomes the transition probability matrix. So, that means that I can write it here, and this one has a very, very interesting, I can write it here explicitly, matrix P you can see that 0, 1, 2 up to a plus b. So, this is basically for n, and this is for n plus 1. So, this is again 0, 1, 2 up to a plus b. As I said that a and b both are non-negative integers, or rather positive integers rather. Okay. So, you can see that this becomes equal to 1, this becomes equal to 1. Okay. And from any point I, you can move, and these are all becomes equal to 0. These are all becomes equal to 0. Okay. From 1, you can go one step forward with probability p, and you can go one step backward with probability 1 minus p. Rest of them are 0. Similarly, from 2, you can go back one step, which is 1, which is 1 minus p, or you can move one step, which is p, and so on. It is a plus b minus 1. Here it is. You can see that from a plus b minus 1, you can move to a plus b with probability p, or you can move to one step backward with 1 minus p. Okay? So, this becomes the transition probability matrix of this particular, what we call the 2% zero sum game. Okay? And say this is one of the Markov chain. We will be studying it. We will be coming back again and again, and we will be studying this one. And the interesting part of these things, you can see that there are certain properties of the different states. Okay? So one of the natural question is, so suppose my A is equal to 50, B is equal to 50. Okay? So the total amount of money, say, is 100. Okay? So one of the natural question is, suppose you start playing the game and you know that the total amount of money A and B has 100 units, what is the expected duration of the game? Okay? That is one of the very, very natural thing, because we know this one, that the expected duration basically means that when you will hit either 0 or when you will hit A plus B. Okay? So, because you know that once you hit there, you get stuck, you cannot come out from there. Okay? And that is the reason that those two states are called absorbing states. You get absorbed there. Okay? So, one of the natural question is, what do you think, what will be the expected duration of the game? If you start, what is expected duration? Okay? And intuitively, of course, it makes sense. It says this one, that well, if you start very close to 0 or if you start very close to 100, of course, the expected duration will be small. Okay? On the other hand, if you start in between, somewhere in between, the expected duration will be large. Okay? And that is precisely what we will see this one also, and those things will come out. Those things will come out from the theoretical analysis also. Okay? So that's the reason the stochastic process, I mean, all this Markov chain becomes a very, very interesting one. Okay? So this is one of the very, very, you will see this one, this particular the transition probability matrix will come up again and again. Okay? Slightly different variations from here, which comes out from here itself. Suppose one of the player, I mean either A or B, has infinite amount of fortune. That means one of them, either A or B, is infinity. Okay? So they start with infinite amount of fortune, which is usually happens. I mean, if you go to a casino, okay, and you play it against that particular machine and all these things, they have an infinite amount of fortune. So if one of them, if one of the player has infinite amount of fortune, so in that case, you will see this one, that it will basically go 0, 1, 2, 3. This is no more a finite matrix actually, but it is an infinite matrix. Okay? So it goes like this, and here also it goes like that. Okay? So you can see that, but one of them has a finite amount of money. So if he can reach 0, okay, and that is what it is. I mean, I am taking it here without loss of generality. Suppose A has finite amount of money and B has infinite amount of money, then actually it will go like this. Okay? So it will from A plus B, it can go to A plus B minus 1 and so on. So this will continue. Okay? So that is a slight variations. That means that one of them has infinite amount of money. Okay? That is what it is. So I have to change it also accordingly. X n plus 1 is equal to j, given x n is equal to I, is equal to p, j is equal to I plus 1, where your I goes from, I goes from 1 to up to infinity. Okay? 1 minus p is equal to j is equal to I minus 1. This also goes from 1 to infinity. Okay? And you can see that I do not have this one anymore. I do not have this one anymore because I can be infinity actually. Okay? I is not finite. So, it is p 1 minus p, and if I is equal to 0, your j has to be equal to 0 otherwise. So, this is the transition probability matrix in that case. Okay, fine. So, I think I will stop it here and we will continue with this one. Okay, thank you.